Welcome to Daddy and Daughter Electronics. We are continuing to make a really cool clock. Today we will program our AVR chip. And I'm here with Valty and my dad. Let's get started. Meet today's superstar, the USBTiny, which will help us in a lot of stuff in this video.
So this is a USBTiny from AdaFruit. It's one of many AVR programmers that you can buy. Now, what I've done here is I've made a convenient little board for programming AVR chips because they come in two common sizes, actually three, but they all will work with this setup. So I've got two sockets, and then I have a couple of external oscillators here. So if you ever program a chip and tell it, hey, please use an external oscillator, and then you try to program it again, and you don't have one on your programmer board, it's not going to work. So what I've done is we have these two standard in-circuit programming connections. One of them 6 pins, and the other one is 10. And I just made a simple connector on my board, and it's really ugly. If you look at the back of it, you'll see I just made a bunch of connections. And if you buy a AVR programmer, it will tell you what the pinout looks like and which pins you need to connect in order to program one of your chips. By the way, if you have something like an Arduino, it does have a port to be programmed with one of these programmers. So you can still do that with the Arduino as well. So we are going to use the avrdude software in order to program this chip. We're going to show you how that works.
So we use the Makefile to make the targets, which is like help, clean, hex, and all that other crazy stuff, flash, and fuse.
So this has a bunch of rules, doesn't it?
Yep, hex is a program. How do you write it to the chip? You write it to the chip with flash. Not the superhero. And then fuse. To check if it's working, type in avrdude. Okay, and then you go -P ATmega 328-C USBTiny -V, and that's what you type. It worked.
So if we want to
You type make hex, and then all of a sudden a whole bunch of words appear on the screen. To write it to the chip, you type make flash, and then all of a sudden it appears with a whole bunch of other words, and it appears in the chip, and that's when your red light should turn on, right?
This is what should happen when you program your chip with AVRdude. You should see the green light should be on if you have a connection with your computer, and then when I program it, the red light will come on. And so now the red light has also come on, indicating that we are programming our chip.
To write the fuses, you do make fuse, and then a whole bunch of words just appear, and once again your red light should turn on. When you know you're done, it says avrdude done, thank you. He's very polite.
Now, whenever you're using an AVR chip, you have to program the switches called fuses. These fuses determine certain things that are really important about how the chip is going to be used on your setup. So here I've gone to one of many embedded AVR fuse calculators. If you just do a Google search, you will find these. This one is called embedded.com Fusecalc. And to get started here, you will put in your part number, and our part is ATmega 328P. And once you've selected your part, it will come up with a bunch of options. So one of the most important options is the oscillator. So all of these chips come with an internal oscillator, and if you want to run that oscillator, you can, or you can supply an external oscillator. Now for our project, we decided to use the internal oscillator to keep it simple, and something you need to be aware of. By default, this oscillator is 8 megahertz and it gets divided by 8. So you'll see that normally when you come in here, this is checked. If you try to run at 1 megahertz, this will not work. This circuit just won't work for you. So uncheck the box, and that's about all you have to do. So when you do that, if you go down to the bottom, you will see that there are 3 different fuse values. There's a low, high, and an extended value. And when you select different switches, you will see these change. So this is changed to C2, D9, and then FF. Over here, it says, here are your arguments for AVRdude. So you'll notice that our Makefile said, please set the L fuse, the low fuse, to C2, set the high fuse to D9. And this is where those values came from. So again, you have to be careful. If you set it to use an external oscillator and you don't have one, then it's going to be very unhappy with you. A lot of these you can manually check. You can even uncheck a box so that you can never program it again. I don't recommend that unless you like to buy a lot of chips. And that's some of the basics. So again, if you look back at our Makefile, we had our targets and we had our list of things to make. And here's how we make the program itself. We compile it, and then we take that file and we turn it into another form. So this goes from our C file to an object file. And then we use this AVR obj copy file to go from the ELF format that we normally have to hex format, which is what the chip wants. When we call make flash, it uses AVRdude to program this chip. So it's going to write to the flash our source code, our hex code, and when we say make fuse, it's going to program it, and it's going to set those 2 values we just calculated. And that's pretty much it. It's really quite simple once you do it a couple of times.
That's all for this video, and I hope you enjoyed programming with us again. And tune in next time where we are going to start working on buttons. And if you are enjoying these videos and are actually making our clock, comment down below and you'll get a shout out next week.